In this lesson, we will learn about volumetrics and SSS section of the Corona material. Subsurface scattering, or SSS, simulates the effect of light entering an object and scattering beneath its surface. Not all light reflects from a surface. Some of it will penetrate below the surface of an illuminated object. There it will be absorbed by the material and scattered internally. Some of this scattered light will make its way back out of the surface and become visible to the camera. This is known as subsurface scattering, or SSS. SSS is necessary for the realistic rendering of materials such as marble, skin, wax, milk, fruits, honey, and so on. In the scene, we have a dragon model, a backdrop, and a few corona light. We can start the interactive rendering. The key, or the main light, was placed behind the dragon model so we can see the scattering of light through our subject much easier. Then we have this backlight, the front light, and a background light. You can obviously check out the lighting more thoroughly on your own. In the node material editor, we have this default Corona material applied to the dragon model. Let's enable volumetrics and SSS section from the basic tab. And here we have two subsurface scattering modes, volumetric scattering and subsurface scattering. Subsurface scattering mode is for simpler materials that have a defined opaque surface and do not need any refraction or translucency contribution, such as wax, bone, marble, and stuff like that. Notice when the mode is set to subsurface scattering, refraction and translucency sections become grayed out and unavailable. On the other hand, volumetric scattering mode is for more complex materials that, in addition to subsurface scattering, require refraction and or translucency, like orange juice, honey, and caramel, some other fruits, chocolate, and stuff like that. For now, let's set the mode to subsurface scattering. And now we have a bunch of parameters that become available when the mode is set to SSS. Fraction or amount, radius, and scattering color. Our material, as you can see from the preview and in the render, only has a diffuse contribution, no reflection or refraction. Using SSS fraction value, we can decide on how much subsurface scattering we want our material to have. So if I set it to 1 to get the full subsurface scattering effect. Now we are set to control how exactly the SSS effect will look using the radius and scatter color parameters. Scatter radius controls the radius of light scattering in the material. Smaller values, let's say like 5 centimeters, cause the material to scatter less light and to appear more diffuse-like. Higher values like 40 centimeters make the material more translucent. Radius here basically controls the radius of the area each sample affects. Higher values will smooth the appearance of the subsurface scattering. Increasing the radius value can radically change the appearance of the material from looking like leather to marble. When we increase this value, we allow the rays to scatter further beneath the object and therefore seeing stronger SSS effects. So if we set the radius to 5 centimeters, (10), 20, 40, 80, and 160 centimeters, You can see by increasing the radius, the light rays are allowed to scatter further beneath the surface and we get a smoother effect. For now, let's set it to 40 centimeters. Then we have the scatter color, which determines the color that is visible in the shadowy parts of the objects. Let's try a few different colors. So it really depends on what you want to create and then choose a proper subsurface scattering amount, color, and radius. For example, if you want to create a shader, let's say for a green cartoony character, first I would change the diffuse color to a green color, let's say with the RGB values of 42, 179, and 126. And copy the diffuse color to the scatter color, but we can probably change it a bit. Try 71 for the red channel, 179 for the green, and 96 for the blue channel. Change the radius probably to around 20 centimeters. We probably want to have some reflection, so enable reflection, set the reflection level to 100% and glossiness to 0.7. And let's see what we get. And here is our lovely little dragon. Let me rename this material to something like Green Dragon SSS. And create a brand new Corona material and assign it to the object. And this time let's create a marble shader. First load this texture called marble_01. And as I know our dragon model doesn't have any good UVs, I'm gonna first put my marble texture through a Corona triplanar. Set the scale of the triplanar to about 250 centimeters and change the blend amount to 0 and connect it to the diffuse color input. Enable Volumetrics from the Basic tab and change the subsurface scattering mode to SSS and subsurface scattering fraction to around 0.75 and radius to 7 centimeters. I'm going to change the scattering color to a slightly less saturated orange with the RGB values of 255, 110, and 76. And connect the marble texture to the scattering color as well. But set the mix strength for the map to 25%. Now enable reflection and set the glossiness to around 0.9. Now let's see what we get. And here is our marble shader. We can probably work on the highlight compression and increase it to something like 1.75 to make the material look better a bit. But that's it. You can see high resolution renders of these shaders in the render folder of the project files for this course. Can stop the render for now. Now let's talk about volumetric scattering method. We can start with a new material and assign it to our geometry. Enable volumetrics and go to the volumetrics tab. Now in the volumetric scattering section, there are a few parameters that you should be very familiar with from the volumetric effects lesson in the lighting section of the course when we talked about Corona volume material. Actually, instead of assigning a Corona volume material as your global volume material, you can zero out the opacity of a normal Corona material, assign it as the global volume material, and start adjusting the parameters in the volumetric scattering section, and you would get the exact same result as a Corona volume material. For now, let's get back to the default values here and disable opacity. At the beginning of this lesson, we talked about how this mode differs from the SSS mode. Volumetric scattering mode is for more complex materials that, in addition to subsurface scattering, requires refraction and or translucency, like orange juice, honey, caramel, some other fruits, and chocolate. You notice when using the volumetric scattering mode, unlike the SSS mode, refraction and translucency are still available. If I start to adjust the parameters to see some volumetric scattering in our object, for example, use a 50% gray as the absorption color and set the distance to 5 centimeters and scattering color to a blue color with the RGB values of 54, 120, and 210. Nothing has changed in the render. To see volumetric scattering, you need to have translucency and or refraction values bigger than 0. So if I set the translucency fraction to 0.5 and translucency color to pure white, now we start to see that blue volumetric scattering happening. If I disable translucency and enable refraction and set the refraction level to something like 50%, again, we start to see the blue volumetric scattering with some refraction. Let's set the refraction level to 0 for now. To see the raw volumetric scattering without any refraction or translucency, you can zero out the opacity level, which turns the surface completely transparent and allows to see and adjust the volumetric scattering. So let's do that. Absorption distance controls how quickly the light passing through an object will become colored and darker. With a lower value, the light will be very quickly absorbed and it appears more strongly colored and darker, even with thin pieces of the material. With higher values, the light will travel farther through the material before these effects happen, so that even thicker pieces of the material will not show so much coloring and darkening of the light. So if I set the distance to, let's say, 2 centimeters, we get a very dense volumetric scattering effect. And if set to something like 50 centimeters, the volumetric scattering becomes much thinner and much lighter. Let's set it to 10 centimeters for now. Absorption color is the color that the white light will take on after passing through the material by the absorption distance. Absorption color and absorption distance are mutual multipliers. So if I use a darker gray color, the scattering becomes denser, and if I use lighter gray colors, it becomes thinner. And obviously we can use any other color, and in combination with scattering color we can create very complex volumetric scattering effects. Let's try a greenish color, maybe a reddish color, a yellowish color, and for now let's use this saturated pink color. Then we have these 3 scattering parameters: scattering color, directionality, and single bounce only. Scattering color controls the color of the scattering media. It affects the coloring of the light bounced back towards the viewer by the volume of the material. Scattering color controls the color of the light after it is scattered. Let's try a few other colors. Now let's use our old blue color. Directionality controls the direction in which light is scattered. The default of 0 means that light gets scattered evenly in all directions. Positive values like 0.8